AP Cram, Calculus AB, Free Response, Exam Review. Question 9, integrate velocity to find distance. Right Riemann sum. All right, so here we have this table, and from it we're supposed to put together the information that Johanna jogs along a straight path for times that are greater than or equivalent to t minutes or 0 minutes, or less than or equivalent to 40 minutes. That's what's illustrated here in the first row. Johanna's velocity, illustrated in the second row, is given by a differentiable function v. The function isn't written out, but the values are present in the table. Selected values of v of t seen here, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Okay, so we established all that. Now, using correct units, explain the definite integral of v of t dt between 0 and 40 minutes in the context of this particular problem. So I'll give you a moment to collect your thoughts about this. All right, so basically the integral from 0 to 40, this is our definite integral of integration, definite, space of integration, the lower limit being 0 minutes here and the upper limit being 40 minutes here. And this is going to be the total distance Johanna jogs, because you have to think, whenever you differentiate with respect to a particular variable or dimension in this case, which is time, you're essentially getting rid of that dimension. So by getting rid of the time dimension, what we're left with is minutes. You get rid of it everywhere. Okay, what you're left with is meters. So the total distance Johanna jogs in meters over the interval between 0 minutes and 40 minutes is what you're left with, okay? Now, in order to calculate the integral, or the distance that Johanna jogs, we're not given a function that we can just put into our calculator and differentiate over this interval. So a technique that we can use is taking the right Riemann sum, and I'll just briefly explain what I mean by that. So let's say this is the first quadrant of a Cartesian coordinate plane. And let's say this is what our function v of t looks like. It's not actually what it looks like, but just for explanatory purposes, stick with me on this one. All right? And let's say we're going to approximate the first interval between 0 and 12 minutes. Right there, okay? And let's say our second interval between 12 and 20 minutes, we're going to approximate that about right here. And our third interval between 20 and 24 minutes right there, and our last interval between 24 and 40 minutes right there. Note, everything is definitely not drawn to scale, so don't email me with a bunch of questions regarding the scalar accuracy of this drawing. It's just for an explanation, okay? So we can use what's called a right Riemann sum to figure out the value of the integral. When I say right Riemann sum, our first interval is between, let's say, 0 and 12. Instead of using the height on the left side right here, we're going to use the height right here to create a rectangle and approximate our Riemann sum. Same thing right here. We could use this left hand height, but instead we're going to use this. And we're going to make a rectangle. A Riemann sum is just like a bunch of rectangles, and it's a right Riemann sum again because we're considering the height at the right to make our rectangles, okay? So that's what that means. All right, so let's see what this looks like mathematically. So the integral from 0 to 40 of Vt dt is approximately 12 times V of 12. And V of 12 is 200, plus 8 times V of 20. And V of 20 is going to be 240. And the reason why we're using V of 20 again and V of 12 is because we're considering the right-hand value of our rectangles. If we were considering the left-hand value, this would be V of 0, this would be V of 12, V of 20, and so forth. That's not what we're doing. And the 12 comes from the fact that there are 12 spaces for the first interval. The 8 comes from the fact that there are 8 spaces for the second interval between 12 and 20, and so forth. There's 4 spaces between 20 and 24, and I think you get the point. So 4 times V of 24 plus 16 times V of 40. All right, so we have all our values. We simply just basically, replace the notation with actual numerical values, and then we multiply and add. So we get 2400 plus 1920 plus 880 plus another 2400. This is going